This example will show you how good is the normal approximation to the binomial. We are given that the probability of getting exactly 12 heads in 20 flips of coin is 0.120134. Find the error of this approximation by normal distribution. First of all, let's look at how do we get the exact probability of getting 12 heads in 20 flips. X is binomially distributed with n and p, where n equal to 20, p equal to 0.5, and q equal to 1 minus p, also 0.5. Then the probability of x equal to small x is ncx, p power x, 1 minus p power n minus x. Putting n equal to 20, p equal to 0.5, and the probability of x equal to 12 is 20c12, 0.5 power 12, 1 minus 0.5, 20 minus 12, and they'll give me 0.120134 if you press the calculator. Now, if we use a normal approximation, how do we do that? Let's recall some notes first. In the handout, we know that the normal distribution provides a close approximation to the binomial distribution when the number of trial n is large and probability of success on an individual trial p is close to 0.5. However, our n is only 20, not really large. P is close to 0.5, but in fact, normal distribution with a mean mu equal np and standard deviation sigma equal to square root of npq can often be used to approximate binomial probability when n is not that large and p is different quite a bit from 0.5. As long as np is greater than 5 and nq greater than 5. And we also have to do some continuity correction. So now, if we use a normal approximation, mu will be n times p, which is 20 times 0.5, which is 10. Sigma square is npq, is 20 times 0.5 times 0.5, we get 5. So sigma is 2.24. Then we have to do a continuity correction. Probability of getting 12 hits by using normal approximation. This is the probability of x between 11.5 and 12.5 after continuity correction. Then convert to z, where z is x minus mu over sigma, where mu is 10, sigma is 2.24. So this is the same as the probability of z between 11.5 minus 10 over 2.24 and 12.5 minus 10 over 2.24, which gives us z between 0.67 and 1.12. How to find the probability of z between 0.67 and 1.12? As shown in the diagram here, I want the yellow area. Now this is the same as the area from 0 to 1.12 minus the area from 0 to 0.67. Now let's look at a table. The area from 0 to 1.12, we can find that is equal to 0.3686. So I can write down 0.3686 is the area from 0 to 1.12. Then let's find the area from 0 to 0.67. Okay, 0 to 0.67, the area is 0.2486. So I write down the area is 0.2486 and the difference is 0.12. And this is the using normal to find the approximate answer. What is the error now? The error of this approximation, you can find the exact probability, which is 0.0134 minus 0.12, and that is 0.000134. So you find that this approximation is very good.